Today I will be talking about the use of precision tools and techniques in insect pest management. So this is one of the national priority area where many IITs, IIM, and other non-agriculture background students and the faculty members, they are engaged, particularly promoting the agriculture to be a cost-effective one. So in this slide, ICAR-National Rice Research Institute is not behind. So we have also worked in this umbrella. So in collaboration with ISRO, Space Application Center, Ahmedabad. So from 2016 onwards, one collaborative project on hyperspectral remote sensing based pest detection and management, that program is going on. So some of the glimpses of our achievements that will be highlighted in my lecture. Besides what the digital agriculture, particularly the NRRI has done, and particularly myself work in that area, that will also be highlighted. So before going to this topic, so first I'll just have a glimpses of what the Indian agriculture right now. So it supports 17.6% of the world human population, 15% of the world animal population, with 4.2% of the world water, 2.4% of the world land area. So if we go back to the 1950, at the time we are in the position of the ship to mouth. Right now we have acted on the Food Security Act 2013. So that is the testimony of our Indian agriculture. So coming to the stages where we stand, particularly in the agricultural development, if we go back to the 10,000 BC, at that time we are just using the manpower and animal forces for using simple tools and techniques. But right now in agriculture 4.0, that is the present context, we are now using the robotics, the Internet of Things, the artificial intelligence, the machine learning, deep learning. So these are the smart agricultural tools and techniques now we are well versed. So in the farmers, now they can speak to their experts very short span of time. They are getting the solutions without any hesitations or without any problems. So the development of Internet of Things, then big data concept now, the cloud computing, that is one of the important aspects through which a huge amount of data are stored and we could able to access. With the advent of this Internet of Things, so whatever the machinery or tools that has been developed, now it is linked to the cloud servers. And if we are sending the farmers is sending the images of any pest and diseases attacked plant, and in short span of time he is getting the getting the identified sample as well as the advisory services. So that is the agriculture 4.0. So now our success story on the basmati rice. Earlier, if we think about the previous time and now, so now we are annually earning 19,000 crores of INR. So that is the testimony of this basmati rice. So a lot of revenues are being generated. So this is one of the story how this, if we talk about this in basmati story, then this Pusa 1121, that is one of the success story where 820 mm after this expansion, we are getting this our rice. So this is the new vision where our doubling of farmer income, the MS Swaminathan that you might be knowing, we are very much popular. He is our father of green revolution in India. So institution building, focused research and blending the classic and contemporary in science have been a few of the everlasting contribution of Dr. Pal. So following the path led by him, he is the way to evergreen revolution. So right now we are thinking about evergreen revolution, means blue revolution, green revolution, and white revolutions, then yellow revolutions. So now we are talking about the evergreen revolution. So that is the again, we are having the challenges, particularly the emission. So if we will talk about the greenhouse gas emission, now the Paris Agreement, Kyoto protocols. So these are lot of things are talked in the world arena. So I'll just quote here that there is the Ratan Tata's statement: eat your food as your medicine, otherwise you have to eat medicines as your food. So that is very important. Now, not only we are food security or nutritional security we are thinking about, but health is one of the most important part. We have to take care with this clean food, particularly the organic food or this natural foods which are coming through natural farming. So the right to food, that is the one of the important milestone in our agriculture. Now we could able to provide the people of India. Now they are not hungry right now through this National Food Security Act. So these are some of the pillars of the food security, particularly the availability, access, then the utilization and stability. So these are very much important aspects. So why ways to boost Indian agriculture? I will not go in detail, but particularly these three ways: PPP mode, this private public partnership mode could do the investing in a smarter value chain. Particularly, we are focusing on the value chain, then improving the access to ready technology and market, then building farmers' resilience to environmental shocks. So this is nothing but the carbon footprints. Then just before my initiation of this talk, I was talking about the different, now the youths are coming to the agriculture, particularly in this smart agriculture or smart farming. So they are also getting a good amount of money from this venture. Then this is one of the techniques through which we can get the benefits of this smart farming, particularly the remote sensing. So this is the sensing things from a distance. That is the most important thing, that we without touching the anything, we can sense what is there. Even now, the soil content, the what is in the soil, whether it is rich in iron or rich in magnesium or rich in potassium. So that through this remote sensing, hyperspectral remote sensing, we could able to trace out. Certainly, the crop soil health card. Now we are in a position that we can generate the soil health card without the our testing in the laboratory. This soil, we can say that this soil is having rich in the nitrogen or phosphorus or potassium. So this is the advancement of the remote sensing science. So I will not go in detail about this remote sensing here. Particularly, what exactly we sense. The remote sensing is accomplished through the transfer of energy that is either emitted or reflected from a radiating object to a sensor. The sensor reconstitutes this energy either into an image or an electromagnetic signal that can be analyzed further. So particularly what we use in the remote sensing, the satellites, the drones, the airborne satellites or airborne helicopters that we can use. So these are the again there are different methods. Particularly, if we go for the previous one, the panchromatic sensor, then the multispectral sensor, then hyperspectral sensor, and right now we are talking about the ultraspectral sensors. So multispectral sensors that measure the reflected energy within several specific sections, these are called bands of the electromagnetic spectrum. However, this hyperspectral sensor that measures the energy in a narrower and more numerous bands than the multispectral sensors. So, under this hyperspectral sensors, we have a narrower and more numerous bands, but in the multispectral sensors, we have few bands. So the accuracy level in the hyperspectral sensors are much more bigger than the multispectral sensors. So the multispectral images contains around 100 or more contiguous spectral bands that provide a contiguous spectral measurement across the entire electromagnetic spectrum. So particularly in our insect pest management, this hyperspectral sensor has played a pivotal role because there is sometimes similarity in the nutrient, in the disease, and in the insect pests. So if we don't have the narrower or more numerous bands, then certainly it will be very much difficult to identify accurately identify what is the causal organism. So in that way, hyperspectral sensor or hyperspectral remote sensing techniques is much more important for insect pest management. So the application of space technology, particularly you can see this in different arena in our livelihood sector, the utility planning, the natural resources, watershed management, agriculture, industrialization, then land use, land cover, many aspects we are now using this geospatial technology. So who uses this remote sensing and why? Particularly the geographer, the forester, the environmentalist, the geologist, and the farmers, and sheep captain, and urban planner. So these are the applications for which particularly the farmers who wants to keep an eye on how his crops are growing, and if they have been affected by any diseases or insect pests that are being monitored through these remote sensing methods. And they are also getting the forewarnings through these remote sensing methods, and decision support systems are also developed through this remote sensing. So these are the panchromatic I was talking about. I'll skip these things. Then use of the remote sensing in the field of agriculture, particularly the identification of area estimation and monitoring, then crop nutrition deficiency, nutrient deficiency and detection, soil mapping, crop condition assessment, agricultural drought assessment, reflectance modeling, then crop yield modeling, and production forecasting, pest forecasting. So many areas are there. So just a few are reflected here. Then these are some of the target interactions, particularly the radiation, the absorption, transmission, reflection. So how this works, NDVI, BVI, this normalized difference vegetation index, which is generally calculated to measure the greenness or the vigor of the vegetations. If the NDVI will be less, certainly it is considered as the unhealthy. You can see this computation, the healthy, where the NDVI value is 0.72, whereas in the unhealthy condition, it is 0.14. So through this computation, we can conclude that whether it is healthy or unhealthy. Then the use of remote sensing in the field of agriculture, particularly the agricultural drought assessment, reflectance modeling, then crop yield modeling. These are some of the things where we can apply. Particularly now, Government of India has launched this drone for application of the pesticides, where they have given a hefty amount of money as a subsidy to different sectors, particularly the FPO, the farmers, and the government organizations. They are giving 100% support. So the spectral signature of the vegetations. So this is actually where we are working, and we have developed the signatures. Particularly, you might be knowing signatures means that is unique. So we have developed signatures for particular pests and diseases. Here we have worked out the yellow stem borer in rice, the leaf folder, the brown plant hopper, and in diseases we have developed the blast, brown spot, fall spot, and yes, sheath blight. So these things we have developed already, the signatures. Once we are mounting these signatures in the drone, the drone will spray particularly the area where it will be identified for particularly the pest or disease. So accordingly, we will be minimizing the pesticide load on the environment, so also the crop canopy. So the reflectance due to the leaf canopy, how you can see this is the thick leaf, where thin leaf, then coniferous forest and deciduous forest. So based on this, the reflectance level also varies. So then the signature are developed. Then crop monitoring status that we can also measure through this leaf pattern, whether it is there is chlorosis or that there is development of this powdery mildew in this cucurbits. So also if there is damage in the this leaf defoliation, or there will be yellow vein mosaic disease in the in that crop. So use of remote sensing, again combating the diseases and pests from the spectral signatures obtained, whatever in the findings for different types of vegetation, we can easily find sensitive bands. So projection of those bands, sensitive bands, on a thermal imaging map will show us the hotspot where the major damage has occurred. So based on this hotspots, we can go for the application of the pesticides. So next we can use the insecticides or pesticide to spray on the exact hotspot or location instead of spraying it in the entire field. So drastically we can reduce the pesticide quantity as per the need of the that field. So this procedure, as a result, both saves the healthy plants from getting the affected with the insecticides and pesticides, which they don't require. It saves both manpower, money, and pesticides from getting spread to the healthy plants. So the portion red in color, that is are affected where the spraying is to be done. Then these are the drones. I think there is no need to spell out. So there are different types of drones, unmanned aerial vehicles, we call it UAV. However, it is used as a multi-rotor. So it can carry out the impressive range of tasks ranging from the military operations to our agriculture. So and again, then quadcopter. So many things are there. So that's based on the DGCA has classified based on the weight of the payload of the drone. So nano drone that is less than or equal to 250 grams. So where this DGCA approval is not required, we can fly. But there is some restrictions also, where in the particularly the in our aeroplane area, in this airport area, we should not fly. So again, this is the digital sky platform DGC has developed, where every information you can get. The micro, that is 250 grams to 2 kg, and more than 2 kg to 25 kg. Generally, these small drones we used for particularly the pesticide applications. Then medium drone, but for the monitoring, generally we go for the micro drone, where it is 2.5 to 2 kg. So there are many rules and regulations there, particularly for beyond these nano drones, you have to have these remote piloting training certificates. So then drone-based applications I have already discussed earlier. The benefits of using the drone, that that is there. So why we use drones and robotics? It is integrated GIS mapping. Also, we do the increased yields, then saves time and easy of use, and particularly the return on investment is very high. Though in the initial investment is much higher, but in the subsequent it will be so much less. Then detection of the pest and disease by this remote sensing, just I have already discussed how we are doing. Then this management of the pest by this drone spraying. Then precision agriculture, like this precision farming, that is defined as the application of the technologies and principles to manage the spatial and temporal variability associated with all aspects of the agricultural production. So georeferencing the farm and field boundaries. So now very easily we are able to get it. So you can see the results: spraying, scouting, harvest, or data processing, or yield, weed, topography, mapping. So then again, prescription map, the fertigation, the planting, everything now we are able to do through this precision farming. So these are the precision farming cycles. So now a farm can be easily automated by different types of tools and techniques of this remote sensing or GIS or digital tools. So create the farm layout, then the productivity map, all these things we can go do in the precision farming. Then precision agriculture benefits from the satellite-based Earth observations. So now the Government of India, in collaboration with the USDA, has already working on the average NG. Earlier it was average. Average, now it is average new generation. NG means new generation satellite. Through this satellite, we are getting the imagery from the US data, United States Space Applications Center, and we are utilizing for mapping of different horticultural crops, fruit crops, vegetable crops, then our rice, wheat, maize, everything we are able to do. But it is in the domain of Space Application Center, ISRO. Then benefits of the EO data for the agricultural sector, particularly the cost reduction, efficacy, and it is also very much environment friendly, competitive advantage, improvement of the quality of the crops, as well as more informed decision making process, particularly the decision support system. It has a major role for taking the decision whether to go for the application of pesticides or not. So the ecosystem crucial for the benefits of the precision agriculture. Here, these are the things generally we are required: the farming data, the crowd sourcing, the fleet of the agri-boats, then the soil sensors, weather forecast, autonomous tractor, smart drones, and connected livestock. So these are the things for the benefits of the precision agriculture ecosystem now we have created. Then what is smart farm? Smart farming is an emerging concept that refers to the managing farms using the modern information and communication technologies to increase the quality, quantity and quality of the products while optimizing the human labor required. So now here we are using the data analytics, the hardware and software systems, telematics, positioning technologies, communication systems, particularly the mobile technologies, then the software applications, then sensing technologies. These are the tools where we are using this. These are the components of the smart farm. Then internet revolution that you might be knowing this now in 1999, Kelvin Ashton that coined the term the Internet of Things. Now we are now in the stage of the AIoT, the artificial intelligence of things. So where the artificial intelligence as well as the internet is clubbed. So now we are talking, previously IoT was there, now AIoT is there. So in that way, we are advancing. Then IoT based the smart farming cycle. Here, these are the satellite designed for the benefits of the farmers. Already we are using in the year. So national program for use of the space technology in agriculture, it is already in there, where this NADAMS, we go for the drought assessment, crop forecasting, that is in the Fasal Yojana, which was launched in 2007 to 8. Then the crop insurance, this Kisan, this crop insurance using the space technology and geoinformatics. These are the mission mode projects. This Chaman project, again, it is one of the successful project of Government of India. So these are stakeholders. We'll just skip. So our work in collaboration with ISRO, where we have standardized the signatures for different pests and diseases in our farm. This spectroradiometer, using this spectroradiometer, we are assessing the different pests and diseases. We have identified, particularly here, our some of the highlights of our results. The leaf folder we have identified these 505, 677, 716, like this different sensitive bands we have identified. And whenever we will go for the spraying, by mounting this sensitive bands, we can go for the spot application of the pesticides, particularly for the responsible for the leaf folder. Again, in the rice pest forecasting, we have also developed one decision support system. Where
sir, sorry to interrupt. Since we started late, we are running short of time. If you can quickly finish it in another 5 minutes, I'll take up one or two questions, because 5 o'clock we have another meeting.
Yes, just 5 minutes. I will.
Please.
Again, we have developed one alternate energy light trap, which is a sensor-based trap, which distinguishes the and for the first time, this NRRI has got this patent. So I am the inventor of this light trap, and we have very good response from the farmers here. And so far we have already sold 3 lakhs of this species light trap. And rice export app is very popular among the and 176 countries is using this year. And this mobile app has downloads of more than 60,000. So these are the key features where decision support system is also are there. So some of the highlights of the news coverage, what we have developed and innovated. So again, this is the Fasal Yojana. I'm skipping this. So you can see in the last slide. So once we are measuring the reflectance of a crop using the proprietary hyperspectral imaging camera mounted on the drone or manned aircraft, then analyze the spectrum of the reflected light and correlate with the crop and soil characteristics. Based on that, identify the potential problems of the farm, particularly the pest and diseases or nutrient deficiencies or the environmental stresses. Then we can go for the advisory. With this, I conclude my deliberation. Thank you very much for giving me this opportunity, agro information. Thank you.
Thank you very much, sir. Thank you for your informative presentation. I will take up the questions from the participants. In the meantime, can you please stop sharing the screen, sir, so that we can see your full video? Yeah. I'll take up a few questions, sir. The first one is, what is the cost of light trap which you mentioned?
So light trap, it is around the smaller one is 900 plus GST, and the upper version is 1100 plus GST.
Is
and
it
the bigger one is it is around 4100 plus GST.
Okay. Is it available all over India, or how it is?
We have a farm at Maharashtra, so they are manufacturing this one.
Okay.
So they are supplying.
And it is being supplied all over India.
Yes, all over India it is supplied.
If anybody from Karnataka wanted to purchase it, they can contact.
Yes, you can contact me and that farm also. I can give, and you can get it very easy.
Okay. I'll take up the next question, sir. How easy is it for farmers to adapt to new technology in agriculture?
Farmers actually, farmers are generally, they are not so convergent with this smart technologies, but to facilitate this, particularly this one, so the young entrepreneurs, so they are coming in the forefront, and in the custom hiring ways, so they can get the benefits. The farmers can get the benefits because we have a small land holding, small and marginal farmers are there, around more than 85%. So this technology certainly one cannot afford because it is a costly, but through this custom hiring methods, we can go for this.
Okay. Other than pesticide spraying, in what other ways does drone reduce labor usage or costs?
Other than particularly if there is the insect pest or diseases problems or the soil nutrient deficiencies are there, then in that area we can go for the pest monitoring, the crop monitoring. Then we can go for the forecasting based on the data available, because this spectrum is having so much power that even small changes in the plant characteristics, it can trace out. So if in our naked eye, if we are able to visualize the disease symptom, but that symptom might have initiated before 15 or 20 days. So even before 15 to 20 days, that whatever the insect bite or disease inoculum are there, so that can be traced out, and based on that data, we can go for the forecasting, small range for pest forecasting or disease forecasting.
Okay. Sir, do you provide any consultancy services to farmers for upgrading their farm and the smart farms?
We provide to the big farms based on their requirement, and that is since we have a protocol, ICAR has some guidelines. Based on that guidelines, we provide the consultancy. So also the contract research we provide.
Okay. How do you charge for that, sir?
It varies. Yes, it is a customized way. It varies from the volume of the work and the time devoted by the scientist.
Okay. Sir, can you please tell us about your education and career background? What made you take an interest in this particular topic?
Basically, I am agriculture scientist. I did my graduation from Odisha University of Agriculture Technology. My postgraduate in entomology from GB Pant University of Agriculture and Technology, Pantnagar. Then my PhD from Banaras Hindu University, Varanasi. After that, I joined this Pant University as faculty. Then I joined as senior scientist at Indian Institute of Pulses Research, Kanpur. There I spent 5 years. After that, I transferred to this National Rice Research Institute in 2012. So from that years onwards, I'm continuing. Though this remote sensing is one of the area where the physics knowledge is much important and it is much required. And I have this experience, particularly the physics in my initial graduation level, where I spent 1 year, where my physics honors was one of the subject for which I spent 1 year. So with this background, I was inclined towards this area.
Okay, that's very nice to hear, sir. Thank you very much. We have now completed the round of questions. On behalf of agricultureinformation.com, we like to thank Dr. Shyamaranjan Das Mohapatra for the talk and for answering the questions. I like to also thank all the participants in this meeting. This meeting will now be closed.
Thank you, madam.
You are very welcome, sir.
Thank you.